So what you have to do here is FOIL. Okay, you FOIL it out. You wind up with tangent cosine plus tangent sine plus cotangent cosine plus cotangent sine. From there, I'm going to rewrite everything in terms of sines and cosines. So I get sine over cosine times cosine plus sine over cosine times sine plus cosine over sine times cosine plus cosine over sine times sine. Remember, all of those singular values, cosine, sine, they're all over 1. Okay? Every one of those is over 1. You get that. That leaves me, I'm just going to rewrite these separately. Sine squared over cosine plus cosine squared, bless you, over sine plus sine plus cosine. Okay, I just rearranged the orders. You all right with that? Now, in order to make anything else work, I have to have common denominators. Okay? So as I go through that, that means my common denominator is going to be a cosine sine. You okay with that? So I wind up with needs a sine, needs a cosine, needs a sine, needs a cosine. Oh, sorry, needs one of each. Excuse me, got ahead of myself there. So it needs so this would be a sine squared cosine plus cosine squared sine. Okay. Now it looks just awful at that point. I think that I'm doing it differently than I did it yesterday. No big deal. Once again, I'm going to kind of rearrange the order in the numerator. I'm going to kind of put the sines together, the sine cubed, the sine squared, the cosine cubed, cosine squared, because then I can factor those chunks out. Does that make sense? Is that how you did this? You probably did it how I did it the first time around, now that I'm thinking about it. You factor? So if I do this, yeah, I think I went a long way here for some reason. I'll pull up my notes that I did here in a second, see how I did. This should work just fine. Because now I can pull out a sine squared. And if I pull out a cosine squared, I get a sine plus a cosine. Oops. If I group that sine squared and the cosine squared, it just becomes 1. Oh yeah, this works nice now. This becomes 1. You okay with that? Bless you. Now, here's a little bit of the trick. When you have the numerator of two things added together or two things subtracted together with a denominator that's multiplied, that means split them apart as in common denominators. And then you can simplify each piece. Here's what that looks like. And then what drops? You get a pair of 1s here and a pair of 1s here. So here's 1 over cosine, 1 over sine. C becomes C. And I think I did mine a lot faster. Oh, wow. Yeah, I did it a lot quicker. Yeah, that would have been a lot easier. Sorry about that. Or you could have done it the easier way. The easier way? That's a lot there. Or what I did, I worked with the first part, the tangent cotangent, and I rewrote it as sine over cosine plus cosine over sine. Got the common denominator right there. Yeah, it's a lot easier. And then this is times that cosine plus sine. And now that first numerator becomes 1. In order to get the common denominator here, I'd have to put them together. So if I put them together as common denominator is cosine times sine, fraction on the left needs a sine, fraction on the right needs a cosine. It's very similar to when we did that. To get a common denominator, I have to put these two together. Fraction on the left needs an x plus 5, fraction on the right needs an x minus 4. It's just the quick way of writing it out. Okay. Same way, or if you want to break it down even further, common denominator would be 3 times 5. Do you agree? Fraction on the right needs to be multiplied by 5. Fraction on the left needs to be multiplied by 3. It just so happens instead of being numbers, we're using these values of cosines. And then this one works so much quicker. And you just simplify it out that way. I guess maybe next time I'll just look at my notes. But that also shows you there's more than one way to do a problem. I wanted to say that, but I didn't want to offend people that like cats. Skin a beast. There you go. What else do you want to look at? Wow, narrow it down, my lady. Narrow it down. 38? I'm going to check my notes to make sure I didn't screw something up. Well, error 5. Okay, this goes back to now the same step of I can split that fraction, and then it just, each fraction that simplifies out. Does that make sense? So if I go to 38, so in this one, what you have to do is group the first two parts together. If you look at the first two parts, you've got cosine squared, tangent squared, plus sine squared, tangent squared, then there's a plus 1. Between these first two pieces, I can take the tangent out. And then I have cosine squared plus sine squared. I didn't take anything out of the 1, so I just leave it there. What's cosine squared plus sine squared? 1. How many of you guys did that in like 37 steps? Amber, you're shaking your head like you did that a really hard way. Did you change tangents to sines and cosines and get like to the fourths and stuff? You get what? Did you work it out? You probably banged your head against the wall, but you got it. It works. Sometimes the obvious is hiding. just like 1 plus 1 equals 2. Who would have thunk it? All right. What next? 34? Sure. Ooh, I like 34. Hey, top tip. This, hey guys, just a heads up. This next trick that I'm going to show how to set this one up is one that we're going to use when we get to equations a lot. A lot of times when you have equations, you're going to have cosine squared and sine, or a sine squared and regular single value of cosine. So it's completely possible that could happen. This is one of those types of tricks that you can utilize to switch back and forth with that when you get into the same unit, if that makes sense. And what I mean by unit, I mean cosine or a sine or one of the squared ones. Okay? So as I'm going through one like this, notice that you're starting with cosine squared, sine squared, and it's jumping to just being all in cosines, which means I have to switch the sign. Yes, I am. I know that sine squared is equal, well, sine squared plus cosine squared is 1. So if I move the cosine squared over, I know that sine squared will equal 1 minus cosine squared. So I get this. Excuse me. And now you have to distribute your negative. A lot of times what you guys do at this point, you forget that negative times a negative is positive. And that was that whole distribution thing of negatives has been a kind of a reoccurring theme of an Achilles heel of a situation from time to time. I substitute sine squared. Sine squared can be rewritten as 1 minus cosine squared. No. Okay. What else do you want to look at? 36. All I'm doing is working left to make it look like the right. No. Yeah, stop that. Just go make, you want to, whenever you see the word verify, that means make the left look like the right. This is another very common style problem. A lot of times when you start with addition between two and you end with multiplication, that just meant that there had to be some sort of a common denominator to make it work. You had to get some sort of common denominator to change addition or subtraction into a multiplication. So in order to do that, to get a common denominator, means I got to rewrite secant, cosecant as sines and cosines. So I write it as 1 over cosine squared plus 1 over sine squared. And then from there, the common denominator would be cosine squared, sine squared. Fraction on the left needs a sine squared. Fraction on the right needs a cosine squared. And then what is sine squared plus cosine squared? And then you get that when you simplify. It's a very, very, very common problem. Whether it's secants and cosecants, secant plus cosecant, or sometimes it's sine plus cosine. But there's a very common style of when you go from addition to multiplication, there had to have been some sort of a common denominator to make it work. One time I actually had keys in my pocket and my ID is weird. I bet you there's an easier way to do this one. This is 32. Yeah. So in order to make this one work, a lot of times people will try and go right off the bat, and you can do distributive property. If you do distributive property, that the easiest thing you would do first of all is I'd rewrite these in terms of sines and cosines. I just realized to do distributive property as opposed to what I just did on my sheet. On my sheet, I went to the parentheses and I got a common denominator, and I wound up taking longer than I needed to. But if I do it this way, if I distribute the sine squared in, you get sine squared over sine squared plus sine squared over cosine squared, which is 1 plus tangent squared, which equals secant squared. I did mine a lot different. So if you look at it on the board or anything like that, you would have seen that I went a lot longer than I needed to. I went from the addition part, got a common denominator, and I got cosine squared plus sine squared in my numerator, and then I did sine squared and it simplified out and wound up with just a secant. That still works. Yeah, that's, now that you look at it twice, I'm like, oh, that's a lot easier. Sir, oh sorry, one second.
Well, because like the way I did was just like multiplying by sine squared is the same as divided by cosine squared, so I just did that.
Yeah. Yes, sir. You have $1? I've been doing these for free for too long. We need to start like donating money to people and charities.
It's very good cause.
Ooh, I like this one. Yeah. You did? Nice.
I don't and the other couldn't get like 38.
So this is one of those types. This is one of those types that you really get kind of pissed at, for lack of better terms, if you're not sure how to set it up. When I see secant, when I see reciprocal property stuff with addition, and I have addition in my denominators as well, in the back of my mind, I start thinking, okay, this is going to turn into a complex fraction that needs 2 sets of common denominators. Okay. So what I'm going to do is this. I'm going to rewrite everything in terms of sines and cosines. And then I'm going to simplify or get common denominators for each part independently. Okay. Now, when you see that you have 1 over cosine, 1 over sine, obviously that means that your denominator is going to be cosine sine. So that means that my numerator is going to be sine plus cosine over cosine sine. You okay with that? My denominator, or my secondary fraction here, this is the same thing as 1 over 1. It needs a denominator of a cosine, so it's just going to be a cosine plus a sine. Now, sorry, when you bring up that bottom denominator part, what do you have to do to it? Correct. So now it's fraction divided by fraction. It's the same thing as fraction multiplied by the bottom fraction's reciprocal. Isn't cosine plus sine the same thing as sine plus cosine? 2 plus 3 is 3 plus 2. And you wind up, is the sine wearing a flotation device? No, he's drowning. Drowning in the sorrow that is trigonometric identity. The what? Oh, that's it. You said that before, didn't you? I forgot what that meant. You mean like pull over? If you're in a sinkhole, all right, so you pop the window. Well, I don't know what it stands for. I've tried a pogo stick. We. You're probably right that that's not it. You're probably right that's not it. Okay, try this one. This is 37 on here. This is another verify. Yeah, we're just gonna add through these things. I want you guys to hold this because I've got some other ones we're gonna look at today. I think we're gonna be fine with one more day of this because I don't want to get them overly complicated that you're gonna like really hate me. I don't mind the fact that you hate this, but the really hate makes me sad. So I think we'll be fine with just one more day of this, and then tomorrow we'll start with the trig equations with some of these things. We'll be fine. So, what is it? If you do that, you have to do that to both sides of the equation. Are we working with both sides of the equation? What do you think you got to do? I can't take out a root 2. How do I take out a root 2? Well, all right, hold on. What's any different from this? How would you simplify that? All right, let's think of this. How do you simplify that? Oh. It's a difference of squares, isn't it? It's a difference of squares, right? Is this a perfect square? Is that a perfect square? Is that a subtraction symbol? Yeah. Okay. Is that a perfect square? Is that a perfect square? Is that a subtraction symbol? Okay. Is that a perfect square? Is that a perfect square? Is that a subtraction symbol? I'm sorry, I didn't hear you. And then what happens? There are so many parts of this stuff that you have done and you've done well. Okay? You've done this kind of stuff before. The only thing that is different a lot of times with this is that you're adding more letters. The process by which you're using the algebra skills that you have are the same. Cotangent plus tangent equals cosecant times secant. What's the tip of the trick of the thing that I've said about when you go from addition to multiplication? Get a common denominator, okay? Which means you have to do what with the cotangent and tangent? Very good, go for it. You know, at the very end, you got a great Ah. I hope that you started it like that. All right. See? I told you you could do this. What's the common denominator now? Okay. Fraction on the left needs a. Fraction on the right needs a. See? It's okay. You can do this. That may or may not be something. Good for you. These problems are fun and also cool and puzzles and transfer. Makes me smile. Oh man. You're excited, right? You love this. So let's see here. Excuse me. So let's try this real quick. As you peruse through these, which one of these is making you just go, ah, just right away by looking at it? No. And let's see. 11? All right, let's start with 11. So, are you taking back number 11? Are you taking back 11? All right, I'm asking, which one looks like it's the most awful? 10? I'm pretty sure we did 10. I'm pretty sure it said tangent plus cotangent times sine plus cosine earlier. 16? All right, we look at 16. So, again, if I'm looking at 16 here, guys, notice you've got two things being added together in the numerator and two things being added together in the denominator, which is probably leading you to do what with them? It's the double fraction. It's going to force you into a complex fraction because if you notice, tangent is itself a fraction. Secant is a fraction. So rewrite in terms of sines and cosines. And then get your common denominators. Okay? And it works rather quickly from there. What I'm trying to get you guys, by asking you guys what you think is the scariest, it kind of takes away that, and it makes your brain less hurtful and hateful and scary and stuff. Okay? So if I go from here, what's my common denominator for the top? It's cosine, good. So I have a sine, cosine, plus a sine all over a cosine. Okay. Now, can I rewrite that as sine times cosine plus 1? Does that change anything? The only reason that I did that is because I saw my denominator of the other fraction. It's got a cosine in it. Okay, I'm preemptive strike. So now I take sine cosine plus 1 over a cosine, and then I multiply it by cosine over cosine plus 1. Guess what I get? It's so cathartic. Makes you feel good. It's like a great release when you're like, ah. So again, it may look awful, like Mackie, but deep down, but deep down, it's nice and easy to work with. I tried, Becky. I tried to bail you out of that one. I was trying to give you a compliment, even though, things. I didn't call him ugly. I said like. It's different than saying, Becky, you're ugly, or it's ugly kind of like. There's a subtle difference. It's subtle and yet discreet. I'm sorry, what's that? Oh, what do these two terms have in common? So I factored it out. Yes. Sure. Do. 15. What's that? So what I would do here is I'm going to treat them as two separate complex fractions. Okay? So I have a sine over cosine divided by 1 over cosine. Cosine over sine divided by 1 over sine. Because now, when I bring this one up to flip, I get sine and I get sine plus cosine. Now, what I would do here, and you're gonna hate me for this one. 2. Let me ask you this: if I had what's another way to rewrite that? Yeah. So if you look at number 2 now, you've got 1 minus 1 plus cosine all over sine. I just separate it. Yep. You're not dumb. You're not dumb. You just didn't recognize it. Don't say you're dumb. Yep. And that's the thing. And that's what I want you guys to get through the barrier of don't overthink it. Yes, sir. Which one? I did that one. I did that when we had that same problem from last time.
Oh, yeah.
Which one? I'm not mistaken on this one. Yep, I got it. So this one's weird. Are you okay with that? Okay. Now, how can I rewrite sine squared in terms of a cosine? Oh, 1 minus cosine. Okay. So now I get cosine plus 1 over cosine, 1 minus cosine squared times the sine. Now it becomes a little weird. Just a little. Is 1 a perfect square? Is cosine squared a perfect square? Is that a subtraction symbol? And remember that numerator can be treated as a term, so that your numerator goes away, and you get 1 over. It'll be, what is that? 1 minus cosine, and then it's all times sine. And then from there, you can it should go, yeah, all they did was they bring the sine up, and you can cosecant over 1 minus cosine. What's that? Yeah, that one's a little weird. I'll give you that one. I think that might be the weirdest. You should be able to finish those. You should be able to knock those out. Honestly, you'll be able to knock those out. These are all go from the left to make it look like the right. Do not touch anything on the right-hand side until you're done. I will do my best to have a copy of it posted on the window by the end of the day. If not, I'll take a picture of it and I'll put it up on the website as well. Super exciting, fun time. It's just a puzzle. Oh, sure. You look like welcome.